Okay, so continuing here, we have a clever observation to make. We'll notice that this perpendicular, when I do a dot product with D, I'm going to get 0, okay, because of this right angle here. So let's go ahead and do that. So U minus the projection, also known as the perpendicular. If I dot that with D, I'm going to get 0. Because the dot product of orthogonal vectors is 0. Okay, now we're going to notice that projection is some multiple of D. So I get U minus, so this is going to be replaced with KD. And then if I expand this, I promise this is going somewhere. I promise. It's a bit difficult doing proofs or reading proofs, because it all comes together in the end sometimes. Anyways, what am I trying to do? I'm going to try to find K. Okay, all this nonsense is to try to find K, or try to find a nice formula for K. And then we'll be in business. So I'm going to solve for K here. So I solve for K here, and I get K is equal to U dot D over D dot D. Which tells me, looking back here, that projection onto D of U is U dot D over D dot D in the direction of D. I'll put all my little arrows on top there, and then we are good to go. All right, so we have two things here that I want underlined. Okay, formula for the projection and the fact that this perpendicular has the orthogonality property up there. So this is summarized in the following theorem. Here we go. So make sure you copy this into your notes. You'll notice that D dot D has been replaced with D squared. Right there. Okay, let's do an example to get some practice with this. Okay, so I'm going to take a vector, and I'm going to express it as the sum of two vectors. So this is the picture we had before. So we have D here, we got U here, and we want to, whoa, that's a funny perpendicular, so we want to express the vector U as the sum of something parallel to D, which will be my projection, and something perpendicular, which will be my perpendicular. Okay, so U is going to equal from this diagram, U is going to equal the projection plus the perpendicular. Okay, I should be get a little sloppy here. Okay, I should put in the rest of my notation here. And then I can work this out. Now I'll use my formula for the projection, which is U dot D over D dot D in the direction of D. And the perpendicular will be U minus the projection. Okay, looking at U and D here, I can see that U dot D is going to be 2 plus 3 plus 3. D dot D is going to be 1 plus 1 plus 9. And then I have the vector D beside it, like so. And then for this bracket, I have U minus projection. So U is 2 minus 3, 1. And then it's going to be minus this projection. This projection here is going to be the same one as I have here. So I think I'll hold off from writing anything here. So what do I get? I get 8 over 11. 1, negative 1, 3. Plus 2 minus 3, 1. Minus, now I'll take this guy and copy it here. So we get 8 over 11, 1, negative 1, 3, plus. So, 22 minus 8. Oh, this is awkward, this calculation. Try not to do too much in one step. Just, here's my first entry, because the 2 becomes 22 over 11. Then I get minus 33. Looks like a plus 8 over 11 for my second component. And then I get 11 minus 24 over 11. So overall I get 8 over 11, 1 minus 1, 3. Plus, let's bring that 1 over 11 out. 1 over 11, 14, minus 25, minus 13, if I'm not mistaken.